Hello students, let us learn about two-dimensional motion. So why we call this as two-dimensional motion, I will give you clarity. So this is also called a projectile motion or also oblique projection also we will call it. Nothing but what is this, right? So now in childhood you have played many times you have thrown an object into the air. Many times you have thrown, right? So when you throw an object, the object should go in this direction only. You have thrown an object by making an angle theta with the horizontal, right? Means you are not throwing horizontally. Whether even if you throw horizontally, the same thing happens. But if you when you throw the object vertically, the object goes to some height and it will come back. So that you have learned in one dimensional motion because the displacement is only in one direction. But here, if you observe, when you throw an object into the air by making an angle theta with the horizontal, so if there was no gravity and if you neglect the air resistance, the object would have gone in the straight direction with the same initial velocity. Whatever the initial velocity you have given to this, the stone, the stone should go in the same, would have gone in the same direction with the same initial velocity indefinitely, according to Newton's first law. But because of the gravity, if we neglect air resistance, the object follows a curved path, which is called a parabola. The object has followed curved path, right? On analyzing it, we will know that the object has traveled some distance in the vertical direction, right? This is the initial position. In the vertical direction, it has gone it has gone to some extent height, right? And in the horizontal direction, it has gone up to this distance, as the diagram, right? So means the object is traveling in the horizontal direction as well as in the vertical direction. That is what two-dimensional motion, right? Now that is why the object will have velocity, some velocity in the horizontal direction as well as in the vertical direction, as the object is traveling along the horizontal direction and along the vertical direction, right? So that is why we have to divide the initial velocity into two components of velocity. One will be along the horizontal direction, another will be along the vertical direction, right? As now if you see, theta is the angle made with the horizontal. So if you draw here a right angle triangle, this will be adjacent side to the triangle and this will be opposite side to the triangle. You can take like this, parallel vectors you can take like this, right? That you will learn in a vectors chapter, right? So here if you write cos theta is equal to adjacent side, nothing but a horizontal component of velocity. Let us write it by ux, right? Again, hypotenuse u, ux horizontal component of velocity becomes u cos theta. And remember that scientists prove that in the horizontal direction the velocity of the object will never change during the entire path from initial point to the final when it reaches the ground again back. At every point in this projectile motion, at each and every point, the horizontal component of velocity ux u cos theta will be constant, will be same. Nothing but in the horizontal direction the object travels with uniform velocity, and that is why if the velocity is constant, acceleration will be zero. That is why acceleration along the horizontal component of velocity is zero. Now, as the object is going in the upward direction, the velocity of the object gradually decreases, right? And at the maximum height, at somewhere in the at maximum height, the vertical component of velocity becomes zero, and the object starts again in the other direction, right? So sorry, here we cannot say another direction because at each and every point here direction will change, right? At the maximum height the velocity becomes zero, and gradually again the velocity increases, right? Here we cannot say one direction because at each and every point in the path the direction won't be same. Here at each and every point the direction will change, right? Because see here, the direction of velocity at this point is making angle theta with the horizontal, but that is not same here. So the direction of velocity is given by the tangent drawn at that point. At the maximum height, tangent will be parallel to x-axis. Means the angle made by the velocity vector at maximum height is 0 with the horizontal axis, with the in horizontal direction, right? So again, vertical component of velocity. This is opposite side to this theta. Sin. So sin theta is equal to uy by u. Becomes uy is equal to u sin theta. I am not teaching here mathematics. U goes this side, becomes u sin theta. And here the velocity changes. Vertical component of velocity changes at the rate of acceleration due to gravity. Nothing but g value minus 9.8 meters per second square, right? So that is why in case of vertical component of velocity, whatever the you have learnt equations of motion, you have already learnt kinematics. So all those formulas you can apply here also, right? So let us derive for all formulae. Whatever the formula we need here, we derive them, but all we use those formulae only here, right? So that is what. And you must remember that theta is only at the point of projection. I told you just now, at each and every point the angle made by the velocity vector with the horizontal will change. That is why this theta is only at the point of projection, not at all the places. Now acceleration direction will be in whatever the direction the object is traveling, the direction of acceleration will be always vertically downwards. So that is why at this point also the direction of acceleration will be downwards, and this angle is 90 plus theta. So this all comes under Olympiad. So what is the angle made by the acceleration at the point of projection? 90 plus theta. You imagine now, right? So because of the uniformity, you can consider that. So this is making angle theta with the horizontal vertical velocity vector. Now here it became 0, means the velocity vector has rotated through the angle of theta, right? Again, as it reaches from this point to the final point, again it goes through an angle of theta, right? Because of the uniformity, air resistance is neglected, right? So nothing but the velocity vector totally turns through an angle of 2 theta, right? So that is why here at this point the direction of velocity will be in this direction. So this velocity vector has turned through an angle of 2 theta. So this will be again theta, right? So this is 90 degrees. Total angle is 90 degrees. So this angle will be 90 minus theta, right? At this point the angle made by the velocity vector with the acceleration is 90 minus theta, means from point of projection to final point where it reaches, the angle changes from 90 plus theta to 90 minus theta, provided that the angle is made with the acceleration. If you consider here theta, the angle changes from theta to minus theta, right? So this you consider angle as minus theta, right? Because in this direction we consider angle as angle in the negative, angle as negative, right? Thanks for watching. We'll continue with the equations later. This is Olympiad level actually. Let us solve some problems also. Olympiad level problems only we will solve.